Hello and welcome back. Now, in this video, we are going to be looking at the topic continuous random variables for A-level further statistics. Now, I'm going to be working on a past paper questions worksheet. So it's a topical worksheet on this topic. And we're just going to be explaining some very important concepts which you need to know as you're getting ready for the exams. Now, you can download this worksheet down in the description of this video, and you can use it for, for revising and getting yourself ready for the exam. So thank you so much, and let's get into the video. All right, so we're starting with this question here, question number 1, and it says, the continuous random variable x has probability density function f given by f of x is equal to 3/16 of 2 minus root x for values of x ranging between 0 and 1, and 3/16 or 3 over 16 root x for values of x ranging between 1 and 9 or 0 otherwise. All right, so on part A, they say we should find the expectation. All right, so we are going to say for the expectation, okay, e of x, that's going to be equal to the integral of x times 3/16 of 2 minus root x, which is like x power of a half, and that's with respect to x, and that's going to be plus, okay, here the limits are 0 up to 1. And here we also have the integral from 1 up to 9 of x times 3/16, and over root x is like x to the power of negative of a half, okay, and that's with respect to x. So this is the same as saying 3/16 of the integral from 1, actually from 0 up to 1 of, now expanding x, okay, multiplying x into the bracket, we should get 2x minus x to the power of 3 over 2 with respect to x, and that's going to be plus, here I'll factor out 3/16 as well of the integral from 1 up to 9, and multiplying x times this, we get x to the power of a half, and that's with respect to x. Right, so we're now going to do the integration. Right, so integrating here, we'll be having 3/16, and that's 3/16 of, and here integrating 2x gives us, well, x squared, right? And that's going to be minus, and integrating x power 3 over 2 will give us 2/5 of x to the power of 5 over 2, 0 up to 1, and that's going to be plus 3/16 of, and now integrating x power of a half, and that should give us, well, 2/3 of x to the power of 3 over 2, and the limits are 1 up to 9. All right, so let me place the 9 where it should be. So when we have it like this, we can now substitute 1 into the bracket. So we'll be having 3 over 16, and that's off. And substituting 1 into this thing will give us 1 minus 2/5, and substituting 0 into this thing gives us 0, right? So basically, that's just 3/5 we're getting. 1 minus 2/5 is 3/5. All right. And that's going to be plus 3/16 of, and now substituting 9. Okay. Here I'm going to factor out the 2/3. All right. So the 2/3 here, and substituting 9 for x to the power of 3 over 2. The square root of 9 is 3. 3 cubed is 27. And that's going to be 27 minus 1, okay, which is 26. All right. So this is the thing we're going to calculate. So let me just do a quick calculation here to get our answer. All right. And we're getting here 269 over 80. All right. So 269 over 80 is the answer. Okay. That's the expectation we get right here on part A. Now we're moving on to part B, and it says the random variable y is such that y is equal to the square root of x. find the probability density function of y. All right. So here we've got a related variable, basically, right? And they want us to find the probability density function of y, but we're going to start by finding the cumulative distribution function of y, and this is g of y. All right. All right. I'll use capital Y here, of y. And for this one, we are going to say that it's equal to the probability that y is less than or equal to small y. All right. But we know that y is root x, so it's the same as the probability that root x is less than or equal to small y. All right. And we can actually say this is the same as the probability that x is less than or equal to, that is if we square both sides, so less than or equal to y squared. All right. So this is what we'll be having, and this is the same as f of y squared that we're looking for. So we're actually looking for f of y squared. All right. Now, from what we've been given, what we have here is the PDF of f, right? So this is the PDF of f, and we're going to need this. All right. So let me just grab this. Okay. And I'll put it here where we can see it. All right. So here we have the PDF of f, and we need to find the CDF of f. That's how we're going to find f of y squared. All right. So what we're going to do here is I'm going to say to find f of x, the cumulative function of x, we are going to find that through integration. So I'm going to integrate 3 over 16. So 3 over 16 of the integral from 0 up to x. All right, up to a certain value of x. All right, because we want to find the cumulative distribution function. So we integrate up to a certain value x, 2 minus root x with respect to x. So this is going to give us, okay, for the square root of x, I'm going to put x power of a half on there. And that's going to give us 3 over 16. And that's 3 over 16 of integrating 2, we get 2x. And that's minus integrating x power of a half, that's 2/3 of x power of 3 over 2. And that's from 0 up to x. So substituting x, we get 3 over 16 of 2x minus 2/3 x to the power of 3 over 2. And that's going to be minus 0. All right. So essentially we have, if we factor out 2 here, it will be 3 over 8. And that's 3 over 8 of x minus a third of x to the power of 3 over 2. So that is the cumulative function, and this is for the range 0 up to 1, right? So for the range 0 up to 1, the function takes up that form, all right? 3/8 of x minus a third of x power 3 over 2. Now, but we also have the other piece, so we also need to find f of x, and that is for the other range, 1 up to 9. So it's also equal to 3/16. Okay, actually I'll say 3/16 of the integral of 2 minus x power of a half, all right, with respect to x, and that's from 0 up to 1. All right, so that's going to be plus, okay, let me use the right pen. So that's going to be plus the integral, actually I'm now integrating the second piece. That's 3/16 of the integral with the limits 1 up to a certain value of x, and that's for x power of negative a half, and that's with respect to x. So this is actually what we are dealing with right here. All right, so for this, that's going to be 3/16, and that's off. Integrating 2 will give us 2x, and that's minus. Here we get 2/3 of x to the 3 over 2, and that's for 0 up to 1, all right? And that's going to be plus 3/16, and that's off, adding 1 here. So we get 2x to the half, and that's 1 up to x, all right? So this is going to give us 3/16, and that's off. And now we have 2 minus 2/3, which is 4 over 3. And substituting 0 into this thing gives us 0, okay? And that's going to be plus 3 over 16. And substituting x, we just get 2x to the half. And that's going to be minus. Substituting 1, we just get 2. So this simplifies to here. We get a quarter, and that's plus 3. Okay, I'm going to multiply into the bracket here. So we get plus 3/8 of x to the power of a half, and that's minus 3/8. Okay, so this leads to us having f of x being equal to a quarter minus 3/8. Is actually minus an eighth. So we have 3/8 of x to the power of a half, and that's minus an eighth. All right. So this is what we're getting for the other piece. So in general, we are saying, we are actually saying f of x is equal to, and the first one is this. All right. That's 3/8 of x. Okay, let me just write that down. So we got 3/8 of x minus a third of x to the power 3 over 2. And this is for 0, 0, 2, 1. And it also has, because the other one was for 1 up to 9, right? So let's have it like this. So it's like 3/8. Let me use the right pen. So 3/8 of x to the power of a half minus an eighth. All right. And this is for 1 up to 9. Okay. So this is what we're having here. Now, to answer the question for g of y, we said g of y is f of y squared, right? So g of y is equal to f of y squared. And what that means to us is this. It means that we can therefore say g of y is equal to, and for the first piece, it's going to be 3/8 of y squared minus a third. Okay, let me just put it down properly down here so that we have one good thing. All right, so we're saying therefore g of y, okay, is equal to, and for the first piece, that's 3/8, and that's of y squared minus a third of y squared to the 3 over 2, which becomes y cubed. Okay, and the other one, substituting y squared, is just going to be 3/8 of y squared to the power of a half. It's just going to be y, and that's minus an eighth. Now the limits are going to change, all right? We're going to say here since, or let me just put it this way, just do a little table. And I'll say here since we had the substitution y being equal to root x, okay, because that's what we have up here, y is root x. So since we have y being equal to root x, we're therefore saying when x has a value of 0, 1, or 9, okay, because these are the x values, the limits we have. So we also have 9 here. All right. What are the values of y? It means that y will be having, let's use small x and small y, still the same. It means that here we get 0, here we get 1, and the square root of 9 is 3. All right, we'll use positive 3 for this. So this is for 0 up to 1, and this is for 1 up to 3. Okay, so this is now what we have. So we also have to change the limits, basically. All right, so the question requires us to find the probability density function of y, and we have the CDF of y. So to find g of y, we do that by differentiation. Okay, so we will have to differentiate. Okay, so this is going to be equal to, okay, now differentiating this is going to give us 3/8 of 2y minus y squared. Okay, so I've just differentiated this, and this is for 0 up to 1. And here, differentiating, we just get 3/8, and this is for 1 up to 3, and it's 0 otherwise. Okay, so what we have here now is the PDF. That's the PDF of y, and that's basically how we do it. That's the answer here. All right, so we're going to move on to another question. Now we're on question number 2, all right? And on question number 2, it says, the continuous random variable x has probability density function f given by f of x is equal to a fifth of x for values between 0 and 2, 2/15 of 5 minus x for values between 2 and 5, or 0 otherwise. So they say we should find the cumulative distribution function of x. So the CDF of x. All right. So to find the CDF, okay, I want you to remember we said if we're moving from a PDF to a CDF, we do that through integration. So you integrate. But if you're moving, so this way, right? If you're moving from a CDF and you want to find a PDF, you do that by differentiation. So you differentiate. So in this particular case, we want to find the CDF from a PDF. So we have to do integration, right? So we are going to say here for 0 up to 2, right? The CDF is going to be f of x equals the integral of a fifth of x, and that's from 0 to a certain value of x, and that's with respect to x, and that's going to give us here, integrating, we get a 10th of x squared from 0 up to x. Substituting x, we just get a 10th of x squared, and that's it. And for the range of values, that's from 2 to 5. So 2 to 5, f of x will be, now for 2 to 5, remember this is cumulative distribution function. It has to incorporate everything in the range 0 up to 2. So we start by integrating a fifth of x from 0 up to 2 with respect to x, and plus the integral from 2 up to a certain value of x, and that's 2/15 of 5 minus x with respect to x. So that's basically how we're going to be doing it. All right, so we know that here we get a 10th of x squared from 0 up to 2. and that's going to be plus 2/15, and that's off 5x minus half x squared, and that's from 2 up to x. All right. So we got little space, so we're just going to maximize the space we got. So we got this here. I'm going to move this up maybe to this line, and I'm going to move this up again so that we got enough space to do what we need to do. All right, so substituting 2 into this, 2 squared, that's going to be 4/10, which is 2/5 that we get, and that's going to be plus 2/15 off. Substituting x is just going to be 5x minus half x squared. All right, and that's going to be minus, now substituting 2, that's going to be minus 10 plus 2. Okay, so this is basically what we'll be having, and that's going to be 2/5 plus 2/15 of 5x minus half x squared. And for the minus 10 plus 2, that's minus 8. And minus 8 times 2/15 is going to give us minus 16/5. So that is actually over 15. So that's what we get. So I just multiplied this by this 2 and this by this. All right. So I'm going to say here 2/5 minus 16/15. That's going to be, well, that's 6 minus 16. That's minus 10. Minus 10/15 is like minus 2/3. So it's like we have 2/15 of 5x minus half x squared, and that's going to be minus 2/3 essentially. Now from here, we can factor out a half from this, so that's 2/15 of a half, and factoring out a half, we get 10x minus x squared here, and that's minus 2/3, and here they divide, so we end up having, let me put it here, a fifth or a 15th of 10x minus x squared minus 2/3. Okay, that'll be the answer. So you need to understand that here I'm now just simplifying, but as long as you get something, even up to this stage, or any equivalent, usually in the mark scheme, they can say OE, or which means or equivalent. So even if you have something equivalent to this, even without simplifying it to this point, you're still good. All right. So don't worry about the further simplifications. You're still all right if you can just express it well, reasonably, leaving it simplified. So we can now say that f of x is equal to, and we got a 10th of x squared for 0 up to 2. And let me move this to the right a little. We also have a 15th of 10x minus x squared minus 2/3. And that is for 2 up to 5. Okay. And so that's what we're getting for the CDF. All right. You can also say that it is, okay, even we can just leave it like this. It's all right. So we're now on part B, and it says we should find the median value of x. Right, so for the median value of x, we're just going to use f of m, okay, being equal to 0.5. All right, so that's just going to be a 15th of 10m minus m squared minus 2/3 is equal to 0.5. So that's like 10m minus m squared being equal to 0.5 plus 2/3 all times 15. Okay, so I just moved all the constants to the right, and that's going to give us, and that's 35/2 Okay, so we have 35 over 2 here. So it's like 10m minus m squared is equal to 35 over 2, which is the same as 20m minus 2m squared is equal to 35, which is the same as 2m squared minus 20m plus 35 equal to 0. All right, so we're now going to solve this equation. All right, and I'll just use my calculator for convenience. So mod 5 and 3, so 2, negative 20, 35, and I get the values to be 7.74, and the other one 2.26. Okay, so for these two values, we're going to reject the 7.74 because it's way out of the range of values we are working with. So we'll therefore say that the median, therefore, is 2.26. So that's how we do it here. Let's go on to C. On part C, they want us to find e of x squared. All right. So when we're looking for e of x squared, we will need the original function. So let me grab this. Okay, so we have right here the function. All right. All right, so we know that e of x squared basically means the integral for all values of x squared times your function. So in this particular case, for e of x squared, we're going to say that it's equal to the, starting with the first piece, a fifth of the integral from 0 up to 2 of x squared times x, which will be x cubed. Okay, and that's with respect to x, and that's going to be plus 2/15, and that's of the integral from 2 up to 5 of multiplying this by x squared. We get 5x squared minus x cubed with respect to x. All right, so that's what we'll be working with right here. Okay, so from here, we will be having a fifth of integrating x power 3. We get a quarter of x power 4. And that's from 0 up to 2, and that's plus 2/15 of, for 5x squared, that's basically going to be 5 over 3 of x cubed minus a quarter x power 4, and that's for 2 up to 5. All right, so here, this is going to be a fifth of a quarter of 2 to the power 4, which is 16. So we're just saying that a quarter times 16 is 4, right? And that's plus 2/15 of substituting 5. 5 to the power of 3 is, I'm sure it's 125 times 5. We get 625. So 625 over 3 minus substituting 5 to the power 4. 5 to the power 4 is 625 as well. So 625 over 4. Now substituting 4, 2 cubed is 8. 8 times 5, 40. So 40 over 3. And that's going to be plus 2. That's 16 over 4. That's 4. Okay, so that's what we get right here. So, well, we need just to simplify the thing that we got, all right? Because, okay, this is 4/5 plus 2/15 of what's inside the bracket. Okay, so I'll do the calculation. And we're getting here 171 over 4. 171 over 4. And it means that we'll be having now 13 over 2, which is 6.5. So the answer comes out as 6.5. That's the expectation. Let's go on to part D. Part D says we should find the probability that X lies between 1 and 3. All right. So for this, probability for 1 up to 3 is the same as f of 3 minus f of 1. Okay, this is 1, right? So bringing up the cumulative frequency function we got right here. So I'm just going to be making use of it down here. All right, so this is what we're going to be using, all right? So we're saying here, f of 3, 3 lies within the second piece. So that's just going to be 1 over 15 of 10 times 3 minus 3 squared minus 2/3. And that's minus f of 1. 1 lies in the first piece, so it's a 10th of 1 squared. All right, so that's just going to be a 15th of 30 minus 9, that's 21. And that's going to be minus 2/3, and that's going to be minus a 10th. All right, so 21 over 15 is 7 over 5, and that's going to be minus 2/3 minus a 10th. Well, I'll just use my calculator for this real quick. I'm getting 19 over 30, so 19 over 30 for this. Right, so that's what we get on part D. All right, so that's how we do it. We're moving on to question number 3. On question 3, it says the continuous random variable x has cumulative distribution function f given by f of x is equal to 0 for x less than 0, and f of x is equal to 1 over 60 of 16x minus x squared for values of x ranging between 0 and 6, and 1 for x greater than 6. So they say on part A, we should find the interquartile range of x. All right, so let's find the interquartile range. We'll start by finding the upper quartile, okay, which I want to give. Let's call it u, all right? So we know that f of u should be equal to 3/4, all right? So that is something very important. So f of u is equal to 3/4, and that's basically 1 over 60 of 16u minus u squared, okay, is equal to 3/4. So 16u minus u squared is equal to 3/4 times 16, which should give us 45. So u squared minus 16u plus 45 is equal to 0. All right. Now we need to solve this for u, and I'll use my calculator here. So we're going to say right here, okay, mod and 5, 3, 1 equals to negative 16 equals and 45 equals, and we get 12.6, and the other one 3.64. So we're getting these two values of u. All right, and we're going to, considering the range of values we have, which go up to 6, we are going to reject this one here. So the only one we're left with is 3.64. So we're therefore saying, therefore, u is equal to 3.64. All right, we're also going to find the lower quartile. And for the lower quartile, I'm going to call it L. So f of L should be equal to 0.25, okay, which is 1 over 60, actually, yes, of 16L minus L squared is equal to 0.25, okay, or just a quarter. Let's just use a quarter. Okay, so this is going to be 16L minus L squared is equal to 15, okay? And that's L squared minus 16L plus 15 equal to 0. Now from here, we are going to solve this, all right? So to get L, I'll use my calculator and I'll say here 1 equals negative 16 equals and 15 equals, and we get L to be 15 and the other value and 1. Right, so we're going to reject this one. Obviously is too big for the range of values we have, so we're going to get L to be 1 basically. So I'll say therefore, okay, let me use the right pen, L is equal to 1. Now when we have L being equal to 1, we can now find the interquartile range. So I'll say therefore the interquartile range is equal to upper quartile minus lower quartile, which is 3.64 minus 1. So it's 2.64, and that's the answer. So that's how we do it for that particular question. Let's go on to part B. On part B, they say we should find E of x cubed. All right. Now, E of x cubed, in order for us to find that, we need to have the PDF. All right. So let's start from there. Let's start by finding the PDF. And we know that we find that through differentiation. So we differentiate f of x to get the PDF from a cumulative function, because what we have is the cumulative function right above. Right, so I'm just going to copy this because we will need to use it. All right, so we got it here. All right, so I'm just going to put it here so that we can see what's going on. So here it is. Okay, so we are going to say, therefore, f of x is equal to 1 over 60, and that's of 16 minus 2x when we differentiate it, which is also equal to 1 over 60 of, we can factor out to 8 minus x. So it's basically 1 over 30 of 8 minus x. All right, so this is f of x, all right? So we are saying that f of x is equal to 1 over 30 of 8 minus x for values between 0 and 6, and it's 0 otherwise. All right, so when we have that, we can now find E of x cubed to say is the same as 1 over 30 of the integral of x cubed. Okay, so x cubed here of 8 minus x with respect to x, which is the same as 1 over 30 of the integral. This is from 0 up to 6 of the integral from 0 up to 6 of 8x cubed minus x to the power 4 with respect to x, which is the same as 1 over 30, and that's 1 over 30 of, integrating this, we get 2x to the 4 minus a fifth of x to the power of 5. And we'll use the square bracket, and that's 0 up to 6. Okay, so that's what we'll be having right here. So I think we still got little space. Okay, so I think we can make use of that space. I'll actually take the whole thing down so that we really have good space to use. All right, so from here, I'll say that's 1 over 30, and that's of 2 times 6 to the power 4. All right, now 6 to the power 4, 6 to the power 4 is 1296. All right, and multiply that by 2, we get 2592. So we have 2592 minus a fifth of 6 to the power 5. So 6 to the power 5, and that's going to be divided by 5. It's 77776 over 5. Okay, so let's just simplify this because when we substitute 0, we just get 0. All right, so let's just simplify this. Okay, so, and we're getting as a decimal 34.56. So this here is the answer. That's what we get. Let's go on to part C. Now on part C, it says the random variable y is such that y is equal to root x. So they want us to find the probability density function of y. So they want us to find the PDF of y. All right, so let's do the working. Okay, how much space do we have? Okay, we've got this little space. Okay, so we need to find the CDF. Okay, and here it is. And that's the CDF of f. And I'm just going to place it here so we can see it. Oh, did I copy that correctly? Don't think I did. Okay, so this is what we have, and we're going to start by finding the CDF of y, which is g of y, which is the same as the probability that y is less than or equal to small y, which is the same as the probability that root x is less than or equal to y, which is the same as the probability that x is less than or equal to y squared, which is the same as f of y squared, basically. So we are looking for f of y squared, and f of y squared, therefore we're saying g of y is equal to f of y squared, which is 1 over 60 of 16y squared minus y to the power 4. We're just substituting into this, all right? And so this is what we're getting, basically. And now, to find g of y, the PDF, we differentiate the CDF. So therefore, g of y should be equal to 1 over 60, and that's of 32y minus 4y cubed after differentiating g of y. And this is going to be for values between 0 and 6. So I can write that as g of y is equal to 1 over 60 for 32y minus 4y cubed. And this is for the range of values. So we need the range of values. All right. And I'm going to do this. All right. For that, we're going to say these are the values of x and the values of y. And for the values of x, we had limits 0 and 6. So 0, 6. And since y is equal to root x, so 0 and root 6 we got. So these are the limits now. So we are saying that here, this is for 0 and y and root 6, or 0 are the y's. So that's how we find the answer right here. And that's how we do it. Now we're moving on to question number 4. Now on question 4, it says the continuous random variable x has cumulative distribution function f given by f of x is equal to 0 for values of x that are less than 2 and 1 over 60 of x squared minus 1 over 15 for values between 2 and 8, or 1 for greater than 8. Okay, so on part A, they want us to find the probability that x lies between 3 and 6. Now, this is the same as f of 6 minus f of 3. Now, f of 6, okay, when we talk of f of 6, 6 lies between 2 and 8. So it's basically 1 over 60 of 6 squared minus 1 over 15. And that's going to be minus f of 3. Still in the same range. Basically, we only have one piece. So that's going to be minus 1 over 60 of 3 squared minus minus, which becomes plus 1 over 15. So this is equal to 36 over 60 minus 1 over 15 minus 9 over 60 plus 1 over 15. Okay, and we're just going to do the calculation here, and we get 9 over 20. So that's the answer here. That's what we get. All right, so let's move on to part B. Part B says we should find e of root x. All right, so on e of root x, that's the expectation of the square root of x. So we're going to say that this is the same as, actually, for us to find that, we need to make sure that we have the PDF. So we need to find the PDF first. Okay, so we need to find f of x. And we say f of x can be found by differentiating with respect to x, big F of x. All right. So basically that, and that's going to be equal to, now, big F of x, okay, is this. Okay, let me just copy this. Okay. So we're going to say that's differentiating that, we get 1 over 30 of x. Okay, and that's all we get when we differentiate that. And so let me just place it here. So we're saying that f of x is equal to 1 over 30 of x, and that's for 2 to 8 or 0 otherwise. All right, and from here we are going to say for e of root x, which is the same as e of x power of a half, it's equal to 1 over 30 of the integral of x power of a half of x with respect to x, and that's from 2 up to 8. So that's 1 over 30 of the integral, okay, from 2 up to 8 of x to the power of 3 over 2 with respect to x. So what that gives us is 1 over 30, and that's of 2/5 of x to the 5 over 2, and that's from 2 up to 8. All right, and this is going to be 1 over 30 of 2/5 of, substituting 8, we get, that's 8 to the power of 5 over 2, and that's minus 2 to the power of 5 over 2. Right, so this is basically 1 over 75 of 8 to the 5 over 2 minus 2 to the 5 over 2. So I'll use my calculator for this. And I'm getting here 2.34. So that's how we do it for this particular question right here. And that's how we do it. Okay, let's go on to the last part. And that's part C. And part C says we should find the variance of root x. All right, so we know that for variance, say of x, we find that by e of x squared minus the expectation itself squared. In our case, for variance, okay, let me use the right pen. For the variance of root x, we will say that this is equal to, and here we are saying it's e of root x squared. So it'll end up just being x, and that's going to be minus, and here it'll be e of root x squared. Okay, so that's basically what we're doing here. So we need to find the expectation of x, which is, in our particular case, if we use the PDF, we got the PDF to be this, right? So I'll place it down here. Let me just put it on the side, maybe here. All right, so we're basically saying that it's going to be 1 over 30. Okay, let me just put it this way. It's the integral of x of 1 over 30 of x with respect to x, and that's from 2 up to 8. Okay, so this is essentially going to be 1 over 30 of the integral from 2 up to 8 of x squared with respect to x, which gives us 1 over 30 of a third of x cubed from 2 up to 8, and that's going to be equal to 1 over 30 of 8 cubed. Now, when we talk of 8 cubed, okay, let me just write that as 8 cubed over 3 minus 2 cubed over 3 as well. Okay, all right, which is basically 1 over 30 of 8 cubed minus 2 cubed. Now, 8 cubed is 512, and minus 8, that's 504. So we have 504 over 3 here. And we calculate, and we get 5.6. So that's e of x squared, right? So let me place it here for the sake of space. So therefore, to find the variance of root x, we'll say that this is equal to e of x, which we got to be 5.6, minus the expectation of root x squared. The expectation of root x is what we calculated above, which was 2.34. So it's minus 2.34 squared. So we'll use the unrounded figure, all right? And that's going to be, okay, because when we did the calculation, this was the unrounded figure, 2.338. So we'll just say 5.6 minus ants squared, and we get 0.133 for the final answer. So that's how we do it. Now we move on to part D. On D, it says the random variable y is defined by y is equal to x cubed. Find the probability density function of y. Find the probability density function of y. All right, so we have, okay, we're going to start by finding the CDF of y, which is CDF of y, which is the probability, or let's just call that G of y, which is the probability that y is less than or equal to small y, which is the probability that x cubed is less than, this is cubed, is less than or equal to y, which is the same as the probability that x is less than or equal to the cube root of y. So that's basically y to the power of a third. And this is the same as f of y to the power of a third. So we can therefore say g of y is equal to, and if we use the cumulative function, and the cumulative function is what we had originally, let me just copy that, and I'm going to paste it down here. And there we go. So I've just placed it here. So here it is. So we're basically substituting y to the power of a third. So it's just 1 over 60 of y to the power of 2/3, it becomes, minus 1 over 15. we'll also have to change the limits. So we're saying x and y. The values of x limits, we've got 2 and 8. And 2 cubed is 8. And 8 cubed is 512. So we have 512 here. All right, so we are therefore saying that g of y is equal to 1 over 60 of y to the power of 2/3 minus 1 over 15. And this is for values from 8 to 512. Okay, so this is what we're having. So to find the PDF of y, which is small g of y, we'll therefore differentiate. So that's d by dx of big G of y. So we're saying here, this is equal to differentiating this. That's 1 over 60 of 2/3 of y to the power of 2/3 minus 1, which is minus 1/3. So just like this. And when we differentiate negative 1/15th, we get 0. So this will give us 1 over 90 of y to the power negative of 1/3. So we're saying that g of y is equal to 1 over 90 of y to the negative of 1/3, and that's 8 to 512, or 0 otherwise. So that's how we do it for this particular question.